Hello, this is Mr. Collier, and today we're constructing some Voronoi diagrams, and specifically some with more than 3 sites. Okay, with 3 sites it's pretty easy because you can just draw the perpendicular bisectors and they always meet at one vertex. It's pretty easy. It's a little bit trickier with more than 3 sites. So let's check out this here. This is with 4 sites, and you can see all the perpendicular bisectors are drawn. I think they're all in there. Yes, they're all in there. So they're all overlapping, and it's a bit confusing, but if you look carefully here, this is the perpendicular bisector between A and B. So you can start shading this region right here. It's region A. And this line here is a perpendicular bisector between site A and site B. So I think we can shade all the way down to here. And this looks like the region for A. Let's take a look at between C and D here right now. So this looks like the perpendicular bisector, so I can start shading around C. Don't go past this line. This one here appears to be the perpendicular bisector between B and C, so I'm going to shade as far as there. Now let's look between B and D. This is the perpendicular bisector between B and D, so you can simply shade this region. This is the cell for D, and this is the cell for B. Okay, next we're going to look at something called the incremental algorithm. So the instructions are here, but we're basically going to go through the whole procedure. There are 4 sites here, so I'm going to make a Voronoi diagram as if it was like 3 sites, and then add the site D. Okay. So I think the easiest one to do here is actually between A and B. The perpendicular bisector is quite obviously a horizontal line right through the middle there. Okay. So let's just do it with A, B, and C, and then we'll add in D afterwards. So between B and C, well, this is 1 and this is 5, so the middle is going to be 3. It's going to be right there. That's the midpoint, and if you draw the perpendicular bisector, well, this is a slope of 1 over 4. So the perpendicular bisector is going to be -4. So I can go up 4, right 1. Okay, so this is going to be the perpendicular bisector here. And between A and C, well, we can work out the midpoint of AC. Maybe we can do that on the side. The midpoint of AC is, well, A is 1. The x value at C is 5 divided by 2. The y values are 4 and 1 divided by 2. So it looks like it's going to be 3 comma 2.5. 3 comma 2.5 is right there. Okay, and the slope, well, the slope is, actually, let's work it out. So little m is going to be, well, we use these numbers up here, basically 4 minus 1, so that's the y right there. Let's write down the coordinates. This is 1, 4, and this is 5, 1. So it is 4 minus 1 over 1 minus 5. Oh, it is 3 over -4. So if we want the perpendicular slope, it's going to be 4/3. Okay, so no, actually, I come to think of it, I probably didn't need to even find that slope, because I know that if it's a 3-site Venn diagram, they're going to meet at one vertex. So I can just draw actually a line from here. Alright, so then we're going to draw that. Alright, so let me change my eraser. So this is what the Venn diagram would look like for 3 sites. Okay, so if we incorporate D now, we can get the resulting Voronoi diagram for 4 sites. So the midpoint of DC is right here. The slope here is -2. So the slope of the perpendicular bisector is going to be 1 over 2, so we can start drawing the perpendicular bisector. It looks like that. Okay. And we'll need the perpendicular bisector between A and D, which is right there. The midpoint is right there. This is a slope of negative 1/3, so the slope of the perpendicular bisector is going to be 3 over 1, so like that. And we can draw the perpendicular bisector there. It's better with a ruler, you get more accurate diagram, right? Okay, so it looks a bit messed up right now. And we also need the perpendicular bisector between B and D. And I believe that, so this is 1 and 4. So it's going to be at 2.5. So the perpendicular bisector, is it going to go at 2.5? Yeah. 2.5. And the y values are 0 and 3. So it's 2.5, 2.5. So it's right there. Is it 2.5? 2.5, 1.5, sorry. Yes, that makes more sense. So that's the midpoint there. This is a slope of 1, so your perpendicular bisector, I should have probably done this in a different color, is going to have a slope of negative 1. So now you can see all that stuff in the middle doesn't count because all these regions are closest to D, and you can start erasing this. So there's your resulting four-site Voronoi diagram. Okay, let's look at this next part here. We're going to add a new fire station to this Voronoi diagram. So all the sites in this problem represent fire stations. So at 2, 1, 2, 1's right there. And I guess we'll call that point E. And let's work out the resulting Voronoi diagram. So obviously between B and E, the midpoint is right there. This is a slope of 1. So the perpendicular bisector slope is going to be negative 1. So let's draw this line. And we have between E and A, the midpoint looks to be right there. Okay. And we know that they're going to meet at this one right here because the three edges will meet at a vertex. So we're going to have this situation, and it's going to go all the way over to here. Between D and E, the midpoint is here. Okay, so we can start drawing that perpendicular bisector between D and E. And between E and C is obviously right here. And it's going to be a vertical line. So it looks like it's going to intersect right there. Okay, so you get this new cell containing all the points that are closest to fire station E. And this is the resulting Voronoi diagram.